Hi there, Andrew Jackson, AJ Design Studio. Got a video today that's looking at the M1 MacBook Air. I've had a few days a bit quieter with work, and I felt like working on something that was geometric but also with some surfacing challenges in there. So I've modelled up the main exterior form, and I think I'll probably follow up this video at a later date with more details like the feet, etc., and then populating the maybe the keyboard. We'll see how we go. Anyway, so this is the result. I've tried to use G3 blends everywhere I can, so it's the result's fairly smooth. Okay, so as you can see here, this is the top, the lid, the screen running into the corner there. That's pretty smooth. The corners on the top you might think are all the same, but they're actually different because one of the faces, the front face on this product, is angled, whereas the others, as far as I can tell, are perpendicular or normal to like the desk. So that's the front. On the back, I've also made some other discoveries about the product, which I'll get into soon. Like this edge band isn't actually, there's actually a crease that runs between the edge, the outside case, and the bottom cover around the corners, whereas around the sides here, as far as I can tell, the edge and the bottom case are one surface, or the same surface split out. Okay, so I'm just going to roll back up through the tree and roll forwards and explain what I've done. First thing I did was survey the product and capture so the main edges, planes, pivot for the screen, etc. I measured this as well as I could with a straight edge across the top and vernier caliper, etc., to try and get through, find out where these virtual centers were, because obviously the top and the underside roll up, and I've named everything in there. I'll upload this file in case anybody wants to have a look. So then after that, the side elevation control, I've got a plan control, which is the width of the product, and then I've got into the base form. Some things I learnt, like, or what I mentioned before, so the back edge is vertical, the front edge is not, it's on an angle. It looks to be normal to the, or perpendicular to the plane that the screen lies on. Okay, so little things like this sort of, can catch you out when you actually start building the corners, because that face is angling over. Okay, so first thing I did was create a boss extrude. So I've used that control sketch, converted some entities and extruded out this boss here, using this corner point of my plane control. And then I've turned that into a surface body by deleting a face on the center line. And then I have defined a plane for the screen top. So that's basically a plane that's on that surface. Next up is the corners. So with these sorts of G3 corners, it's quite hard to measure how full or how flat the corners are, just by looking at them. So what I've done is I've taken a diagonal measurement across the product, which is like a diagonal maximum. So I'm using this point to bring the corners back through. I'll show you in a second. So because the top and bottom are different, because of the angle on the front face, I've had to, and also because the top is on the angle, I've had to create these measurements on two different planes. Okay, so the front bottom corner is a G3 corner, so it is a degree 7 style spline, so that's got 8 CVs, and I have this setback radius here. So from the virtual corner, I have set back, like this is where the corner starts, where the edge transitions from a line into the spline, and I've treated that to be equally in both directions. And what I mentioned before about this diagonal measurement, so that's that line there. So I measured across the product, that seemed to be its maximum diagonal distance. So I have constrained this style spline to meet that point there. So that kind of controls the fullness of this curve here. And then I have an equation, because these corners get set up elsewhere, which controls these dimensions here, and also the setback from the corner. Okay, and that results in a G3 corner, and actually I ended up in none of my sketches I've had to use a tangent or a curvature continuous or a G3 constraint, because everything here is matching to a line or a linear edge. So if you just make your control polygon segments collinear to the edge that you're matching, you don't need to use a G3 constraint. So I've built the top and bottom. I won't go into this other one here. That's why I had to share those dimensions, because these are this face here is canted over and this face is vertical, so these corners are slightly, ever so slightly different. Whereas on the rear, for the rear bottom corner, I'm just going to extrude that up because these faces here are perpendicular to the top plane. The front corner is a boundary surface, and that's just using those two sketches, and I haven't put any constraints, or I don't even have any curves in the second direction. Okay, and I've created a 3D sketch and I've trimmed that back out into that main body. And if we run a deviation analysis on those edges, so I've got 0 degrees deviation there, so those are all good, even though I didn't need to specify that. I didn't specify that boundary or make it tangent. Okay, and the rear corner is just a straight extrude, surface extrude, and then trimmed and knitted into that. Okay, so that's the main like blank form with G3 corners. Okay, next up is the top pillow, so the pillow on the lid or the screen, whatever you want to call it. Okay, so again, to measure this, like the break point, where, because the exterior of the screen is a planar surface in the middle, at some point it breaks and then it turns into a G3 surface. So to figure out that distance, I lay a straight edge across the top with strong backlighting so I could see where it was touching, and then I basically added some more, because with G3 surfaces you always need more distance to allow the surface to curve. Okay, so that is an equal setback from each edge, 40 millimeters, and then again it's a degree 7 style spline, so it's set up like the outside corner, except in this case I've made each of the control polygon segments equal length, so there's no other constraint or dimension controlling that. And I did that because I sort of played around and changing this and making it a little bit pointier, etc. It didn't actually have a massive effect on the form. Okay, then we've added a split line to the top, and next I'm going to add the split line for where the edge is, for where the surface runs down to a sharp edge on the exterior. So another split line, and then deleted those faces. And then I start adding some surface extrudes. So these extrudes, again G3 to the planar top face, and to make that G3 the top face I haven't used the G3 constraint. Again, like earlier I said, because we're matching to a linear element, I've just made the first 1, 2, 3, because you need to have 1, 2, 3, 4 CVs to specify G3 constraint. So as you can see here, that's a degree 4, so that's got 5 CVs in it. The last CV here is the free one, and that's G0, so that's coincident to the edge here. And the other 1, 2, 3 control polygon segments are collinear to that edge there. And then I've made them all equal, just because I didn't have a way to measure this angle on the product, so I thought I'll just make these all equal. And the result, it looks okay. So that, we just turn our edges off. That transition from the planar face down to the edge is quite smooth. Okay, so as I said, that's an extrude, and then I basically repeat the same procedure along the other edges. So I've extruded these up to this corner vertice on each, and then basically what I'm going to do is trim these back with a sketch. So I've gone from the corner of this inside to this corner here. I know in some of my earlier videos with pillowed surfaces I did try cutting this piece of surface off and then adding some other geometry in there. I tried that with this, but I actually got just as good a result by going out to the corner like this, and didn't end up with much pinching in here, which is what I was sort of wary about when I did those experiments, like cutting this right back. So okay, knitted that together. I've created a midsection curve, which you can see here, to control this corner surface a bit more. So that's basically, I've created a plane that's offset from the top, and then that plane, it's got a couple of intersection curves, so intersecting these extrudes. Again, didn't need to use G3 constraints to get this style spline to match up with this linear element here and here. Okay, so I've done the same up here. I've got a few dimensions there because this did actually affect the form a bit, so I can change the fullness or how flat that style spline is. And those style splines are set up the same way as that corner there. And then the boundary surface is pretty straightforward. So in this direction it's just these two edges, the edges of the extruded surface, and in the other direction we're tangent to the planar face at the top, and then just got G0 on this outside edge, and then I've got the midsection. And after playing around, I found I got the best result having tangent influence to 0 on these ones, and that's probably because they're influenced by this mid plane curve, so they don't really need tangent influence there, and then tangent influence on this boundary at the top here up to 100%, and then the same over here. Okay, so there's our result with the top corner. I'll just turn the edges off again. So that works quite well. Yeah, no pinching, which is nice. I think that's because this outside corner is G3 as well. Everything I've tried to set up is G3, which means that's translated quite well into this corner surface. Right, let's get onto the bottom pillow. I might just skip. Oh no, the bottom pillow is actually a bit more complicated. Okay, let's have a look. So to start with, I've got the same sort of setup as the top, so I won't go into this detail about how I've created this inner boundary for the planar bottom for the setback. And on the side, that is a split line, like through where the hard edge, where the pillow runs down to the hard edge, and then I've deleted the faces like I did on the top. Okay, and then I have that series of extrudes like the top, and then I trim back. Okay, this is where it starts getting a bit different. So on the underside of this product there is a split between what you might want to call the main case and then the bottom case, and I have controlled that with a pipe. So I've got a pipe setting a distance back here and then intersected with the surface here to give me some of these 3D sketches here. I could have done it with a plane, but I decided to keep it as 3D sketch in case I changed any of these surfaces. So these were, maybe I changed this extrude so it's slightly different to the others. But I'll just jump into another file to explain this issue. Okay, so on an earlier version, this corner I was setting up pretty much the same as the top, except it's got more of a pillow on it. So when I was trying to set up this setback here for the split between the main case and the bottom case, when you look in here, you can see that this has got a big wobble in it. And I thought, okay, well, maybe they just played with the form here until they got rid of this wobble. So they got a consistent, nice, even edge there. But I tried doing that and I couldn't succeed. I was always having a bit of a wobble on this edge here. So I had a really close look at the bottom of the MacBook Air and noticed that there is actually a crease on both of the corners on the underside on the MacBook Air between that pillowed face and this face. So they're actually separate surfaces. Whereas as far as I can tell, this surface and this surface are the same surface, they've just been split. So I thought, okay, well, maybe Apple, for consistency, they made this edge here planar and then made that surface and then made that one without trying to keep tangency across here. So I tried doing the same thing. You don't really notice on the product because there is a 0.05 or whatever gap across here, plus there's a screw here and then there's the foot, so you don't really notice. So my solution was to add a 3D sketch between those, like the setback, like the split between the two parts that I was mentioning. I created this corner ribbon surface. I'll just hide the curvature graph. And it's a little bit complex looking, but so I've created a G3 or a degree 7 style spline as a 3D sketch. And all of the control polygon segments are collinear to these lines here, which means that is effectively a planar section, assuming these two lines lie on the same plane. The reason I didn't build this on a plane was because I wouldn't be able to tell what this angle was. I'd be chasing myself around and around in circles. So I've got control over the depth of this ribbon here on the corner. And I decided to do that because some of my measurements actually looks like this corner is slightly different to the dimension on the side here. I've probably done that for visual purposes. So I can change that dimension there. This stays planar effectively, but this angle here or this segment changes. All makes sense in a second. Okay, so to put a surface in, I've trimmed back these ends of these extruded side surfaces, and then I've made that ribbon surface there. So that ribbon surface is tangent to the main side surfaces on each end, and then I have that both of those elements of that 3D sketch controlling it, and that is effectively planar, the result, that top edge. So we try and make a plane through it. Oops. Okay, so that's nice and controlled now, there's no wobble in it. Okay, I'll just roll forward and put in the main corner, right, which is set up the same way as the top corners. And now if I turn my edges off, actually just roll forward and knit this all together, you'll be able to see the crease. Okay, and we run a deviation analysis on that, you can see there is, what's that, 7.5 degrees of difference in the tangent direction there. Okay, and if you do have one of these products and you have a good look at it, you can actually see that this edge here sticks up ever so slightly above the pillow or the main corner behind it. So now if I turn the edges on, you can see there's no wobble there anymore. So I know this is super sort of detailed and a bit pedantic, but I guess someone was pedantic because that's how the product ended up, right? So I guess if you got super smooth forms on fairly controlled geometric shapes, you've got to be pretty controlled. Okay, I'm going to jump on now to something else. Oh yeah, there's the front one. It's the same thing. So it's nice and consistent because we're going to split these parts out, and that's one of the split lines. Okay, next up, I cap off the center to make this into a solid with a thicken, and then I'm going to split out the screen area, so I'm going to use split functions or features. So to do that, I've created a solid extrude, which is basically the height of where the screen is. So the outside edge here, which is 1.8 millimeters down from the edge. And then I've added a cut extrude at the back there, because this screen comes down and round into the hinge area. And then I've deleted some faces off that solid body to turn this into a surface, because I use that surface then as the split tool to split the screen off. So now I've got the screen isolated up here. Okay. Then the next one is to split off the gasket, what I've called the gasket. So I've created a body like a gap, which I haven't done any detailing or anything on, so I've just hidden the body. And then next up is to split out the bottom cover. So I have created an extruded cut to create this gap here in the bottom, then created a solid extrude, which is basically denoting the split between the main bottom case and then the bottom cover. I've cut that back because I just want this bottom cover to be a solid. I'm not trying to make a thin part at the moment. I just want to make a block. So that's just cut back a nominal distance. Then I've deleted some faces again to turn that into a surface body like that. And then I've gone in and used the split feature to split that body. So if you haven't used the split feature before, I'll just show you. Okay, so this is one solid body here, and then I've got that surface body. If you go insert feature split and you pick your trim tool, which can be surface or a sketch. So there's my trim tool, and then the selected bodies to trim or cut, sorry. Then you go cut bodies, and so that split that into two. I'm going to keep both those. And then you hide the surface, so now we've got two bodies. And those faces that the surface faces that we use to split them, they're coincident, so that's matching up line to line everywhere. Okay, I'll just delete that one because that's going to cause me problems with my other features. Okay, and the last thing I've done is added the little finger cutout at the front for the screen. Okay, and then I've added a few clearances using move face, just to add a clearance between the bottom case and the bottom cover. So we turn the edges off. You can see there, you can sort of see why I didn't really notice that crease at first between that face there and that one. So these faces here, those are the same surfaces. These surfaces aren't on the bottom. Okay, but what that means is you end up with a really nice, equal, deliberate looking result. And I think that's the main thing, you know, you don't want to have a big wobble in the bottom here, because someone will spot it, someone like me. Anyway, just added some fillets and mirrored it all across. So there we go, that's the first stage of the MacBook Air M1 modelled in Solidworks 2020. Yeah, so hopefully I'll follow up with another installment when I've got some more details on, like the feet. And it looks like the feet have some sort of poker yoke design, because I thought the foot would be common across all corners, but after looking online it looks like there's little lugs to locate the feet and rotate them the right way around. So anyway, we'll cross that bridge when we come to it. Okay, thanks for watching. Andrew Jackson, AJ Design Studio. See ya.